Welcome to this explainer. Okay, so if you've ever felt completely bogged down by endless script maintenance or dealing with those soul-crushing deployment failures at 2 in the morning, you are really going to want to pay attention today. We're exploring a massive, literal paradigm shift happening right now in software engineering. We are looking at exactly how AI agents are transforming CI/CD pipelines from these rigid manual bottlenecks into intelligent, self-healing systems. Here's a quick look at our roadmap for today. First, we'll cover the traditional DevOps bottleneck, then the rise of autonomous CI/CD. After that, we'll peek inside agent-driven pipelines, measure the real-world impact, and finally wrap up with how to actually overcome the hurdles of implementing all this. All right, let's jump right into part one, the traditional DevOps bottleneck. To understand why we even need a revolution here, think about how our progression toward faster delivery has evolved over the years. We started way back with that rigid, sequential waterfall approach, right? Then we moved to the more iterative agile era, and eventually we broke down the silos between teams with traditional DevOps. But here's the thing. As the sheer volume, velocity, and complexity of modern microservices has absolutely exploded, human capacity has just been totally outpaced. So autonomous DevOps, it's not just some trendy buzzword, it's the next necessary epoch in software engineering just to handle this immense scale. Let's put a number on that pain. Traditional pipelines are literally buckling under modern complexity. Right now, developers are draining almost 10 hours, well, 9.3 hours to be exact, of their week just doing manual pipeline maintenance. I mean, think about that. That's an entire workday completely lost to untangling bespoke scripts and silencing 3 a.m. alert fatigue, instead of, actually building new features. So that brings us nicely to Section 2, the rise of autonomous CI/CD. The contrast here is huge. The old way is incredibly reactive. It relies heavily on human decision-making and these rigid, brittle scripts. Basically, when something breaks, a human has to drop absolutely everything and go fix it. But the new way, autonomous DevOps, is proactive. It utilizes systems that learn and adapt on the fly. They use predictive analytics to foresee issues before they happen and self-heal in real time. Literally zero human intervention required. At the absolute core of this new era are what we call agent-driven pipelines. Now, instead of just writing static scripts, you're essentially acting as a manager, orchestrating a whole team of digital workers. And to be clear, these aren't just simple chatbots. They are specialized, highly goal-oriented AI agents that actually maintain shared context through centralized memory. They collaborate with each other to parse requirements, generate code, run tests, and provision infrastructure dynamically. It's really fascinating stuff. Let's go a level deeper in Section 3, inside agent-driven pipelines. If you look at a mature, automated MLOps pipeline, data and source code are basically in a state of perpetual motion. Executable packages flow seamlessly from continuous integration right into continuous delivery and model training. It creates this beautifully automated prediction service that continuously monitors live data and feeds metrics straight back into development. The whole loop just keeps spinning, entirely bypassing human bottlenecks. To wrap your head around this, it really helps to anthropomorphize the process into 4 distinct team members, kind of passing a baton. First up, you have the planner agent, who ingests natural language requirements and parses them into a structured spec. Next, the builder agent steps in and actually generates the full stack code, maybe whipping up React components, Node APIs, and database schemas all at once. Then, the critic agent evaluates that code, running static analysis and test suites. And if it finds, say, a missing validation, it just flags it so the builder can self-heal. Finally, once all tests pass, the deployer agent provisions the cloud infrastructure and ships the code to production. Of course, for these agents to reproducibly build and test all that generated code, they rely heavily on robust containerization engines, like Docker. By completely decoupling the execution environments, the agents guarantee that their custom code is perfectly reproducible every single time. This isolation is a game changer because it lets them rapid-fire prototype, test, and tear down builds without ever risking the host system. Okay, the architecture is cool, but let's get into the hard data in Section 4, measuring the impact. Check this out. Organizations with mature, AI-driven test prioritization saw a staggering 72% reduction in test execution time. 72%. Now, you might be thinking, doesn't cutting tests by that much totally sacrifice quality? Actually, no. These smart algorithms ensure that only the tests potentially impacted by specific code changes are run. As a result, those same organizations maintained over 98% of their defect detection capability. So you get drastically faster feedback loops with absolutely zero loss in quality. And the broader return on investment, it's just undeniable. With automated diagnostics, your mean time to recovery, MTTR, drops by 51%. Dynamic resource scaling slashes computing costs by nearly 45%. Plus, because these intelligent agents evaluate deployment risk before anything goes live, change failures decrease by a massive 44%. But honestly, beyond the financial metrics, there is a massive human element here that we can't ignore. We are giving engineers their time and, frankly, their sanity back. By offloading all that toolchain fragmentation and alert fatigue to AI, teams actually experience 45% lower stress levels. And less stress naturally leads to higher job satisfaction and significantly better retention rates for your best talent. That brings us to our final part, Section 5, Overcoming Implementation Hurdles. Because let's be real, it's not all sunshine and rainbows. Technical and cultural hurdles are very, very real. Trying to integrate autonomous agents with legacy systems causes compatibility headaches for over 60% of organizations. And honestly, engineers are often, and understandably, resistant to just handing over the keys to an AI. But these challenges are entirely solvable. The trick is to avoid massive overhauls. You want to implement phased rollouts, focus hard on upskilling your current team, and ensure you have comprehensive observability from day one. So the golden rule here is to take an incremental approach. Do not, under any circumstances, try to rip and replace your entire CI/CD infrastructure overnight. Start small with a minimum viable pipeline. Use AI to augment human decisions first. Maybe it just suggests test optimizations to start before you give it full autonomy. And because these agents are going to be modifying production code, you absolutely must secure their access using strict role-based access control inside sandboxes. Finally, make sure every single action the AI takes is logged and fully auditable, tracing right back to its original intent, so you can continuously monitor and truly trust its decisions. I'll leave you with this somewhat provocative thought. This isn't just a simple productivity hack or a fancy new plugin. It is a fundamental, systemic shift in how software is conceptualized, built, tested, and shipped. The technology is already here, the data proves it works, and the only real question left is, how soon will your team join the revolution and let intelligent agents transform your delivery lifecycle? Thanks for joining us for this explainer. We'll see you in the next one.